Hello and welcome to today's webcast. Today we're going to be focusing on how to build a mobile app in less than 60 minutes. We're going to be using a lot of great tools, looking at a lot of demos, and we're going to move kind of quickly. So if you miss anything today, everything's going to be recorded and available on our YouTube channel shortly after the live event. My name is Todd Anglin, and I'm Vice President of Product Strategy and Developer Relations at Telerik, and I will be both your MC, your host, and your demo driver today. If you want to ask questions during or after the webcast, you can always find me on Twitter at Todd Anglin, or you can shoot me an email, todd.anglin@telerik.com. If you have any trouble during today's live event, we have people in the Q&A log there to assist you with audio and video challenges. But again, everything's being recorded, so if you miss anything, you'll be able to grab it on YouTube. The focus of today is to really discuss what does it take to go from idea to device. What are the things that you must learn to do fresh as we move from building software for a single platform and a single form factor for those desktop, PC, and web apps, to building apps that run on multiple platforms on many different screen sizes, really challenging us to rethink all the things we knew how to do that we have to learn fresh for mobile. And if we're to summarize the steps that it takes to be successful going from an idea to a device, there are a number of key activities like designing our applications, building and debugging them, testing them on devices, deploying, and of course, once deployed, observing those applications in the wild to see how users use them, how they're functioning, where they're crashing, so we can make them better. But as you dig into each of these categories within mobile development, you'll find lots of sub-decisions that must be made before you can really be as productive as you want to be building all of these cross-platform mobile apps. So in today's webcast, we're going to take a very pragmatic view and start from scratch and really go through the key steps you need to invest in order to be successful, going all the way from setting up your development environment to eventually deploying your application out to beta testers and users so you can begin collecting feedback and making future versions better. To do that, I'm going to be using Telerik Platform, an end-to-end mobile app development and deployment environment. It provides all the tools and back-end services we need to design our application, debug the UI for our app, connect our app to data and authentication services, and eventually deploy that application out to our testers or our users and wire it up with analytics and feedback so we can figure out how the app is doing and make those versions better as we want to do. And the beauty of the Telerik platform is it brings this all together and integrates it seamlessly so we can easily move through the entire application development lifecycle without a lot of friction or setup, configuration, or hassle. It's all there for us in one place to make our life as easy as possible as we build these cross-platform apps. So that'll be our tool chain. We'll be using Kendo UI Mobile within that for our UI. But let's first talk about the first step in a mobile app development project, and that is setting up your development environment. When we built traditional software for the desktop environment, we had a tight feedback loop between the place where we created our code and where it would eventually run. The machines we developed on were also very much like the machines our users would use and where our code would run, so it was easy to do our coding, debugging, building, and testing all on the same kind of hardware. And we only usually had to set up a single SDK. If we were developing for Windows or maybe for the web, there was not a lot of configuration around SDKs it took to become productive building our apps. As we shift to mobile, it becomes a slightly more complicated setup, particularly if we're doing completely local building and debugging. We'll still likely continue to write most of our code on our primary developer machine, and that'll be configured with our favorite code editors, and then further enhanced with the SDKs we need to build for the various target mobile platforms we're interested in, like Android, iOS, Windows, and potentially others, including even the web platform. If you want to do all of your builds locally, you'll also likely need an additional piece of hardware, or at the very least an additional VM, so that you can build iOS apps on Windows or build Windows apps on a Mac operating system. So right away, we have two pieces of hardware we need to be successful, and two pieces of hardware we must maintain and manage to go between the place we write our code and the place we build our code. And since mobile apps aren't designed to run on desktop machines where we create our code, we also need some additional hardware to do our debugging. We can of course use simulators and emulators to help us in the early debugging phase, but there's no substitute for actually seeing how your code runs on a real physical device, so we have to have some of those available, connected and configured, so we can do debugging on the code we've created and built. And for any robust app going out to a large group of users where the bring your own device environment is in full effect, we want to make sure that our app not only works on the handful of devices we may have locally, but also works on the thousands of permutations of screen size, hardware, operating system that our app may encounter once it's deployed via public app stores. So we'll need an additional testing phase and testing hardware in order to really round out the full story of building and testing our app. If we've configured this all successfully, we will be able to build, debug, and deploy apps that can reach all these different form factors and operating systems and input methods that we really have to be prepared for as we build mobile apps. The challenge with this approach, while very useful and effective, of course, is that we spend a lot of time setting up, configuring, and managing our environment versus spending more of that time creating and enhancing our apps. So if we don't want to spend as much time doing this, another option is to push a lot of those requirements off into the cloud so that we can just focus on our application's code. And this is what Telerik Platform actually does. It abstracts from you the complexities of setting up and managing and maintaining multiple SDKs, device cloud environments for testing your app on hundreds of real physical devices, as well as all the various build servers and build configurations you need to make sure that your app can build for iOS, Android, Windows Phone, and then be published out to the various App Store options. All of this is managed in the cloud, so you can sit down at any development workstation, begin writing code, and everything else is taken care of for you without any additional headache or hassle or wasted time. Of course, you will still need some local devices for debugging, because debugging on a mobile device on the metal is still critical to the app development process. But when you work with a cloud-based solution like Telerik Platform, even with local devices for debugging, you can streamline the process for getting your app onto those devices and before you can start writing your code. So let's start today by setting up our development environment. And I will be using Telerik Platform, so I will be taking advantage of this cloud-based approach and pushing a lot of what I need to do into Telerik Platform, so my configuration is relatively simple. I have a browser open here today that's already been logged into the Telerik Platform, and from a strict setup standpoint to begin creating mobile apps, this is all I have to do. Log into a website in a browser. I can begin writing code, debugging code, running simulators, deploying my code, all from a browser, from any machine I sit down at, because the Telerik Platform is taking care of everything else, all the SDKs for me in the back end. Now, if you were working with another code editor, and a lot of developers have preferred code editors like Visual Studio or Sublime Text or many, many others, then we have many integrations with Telerik Platform to help you write your code and take advantage of these build services wherever you most prefer to write code. One of the options available is a command line interface, and so just to show you what the setup process for that might look like, I've got a terminal window here open on my Mac. On a Windows machine, you might open up a command prompt, and from the Node Package Manager, or NPM, I'm going to go ahead and install globally the App Builder CLI. The App Builder CLI brings in all of the commands I need to be able to do everything I can do building and debugging apps via the browser interface or via Visual Studio plugins into my command line. And since I've already done this step, or taken this step previously, I simply need to come here and say App Builder. And when I do that, I'm going to get a full review of all the commands I can issue via the App Builder CLI, and you can see it's quite a lot. I can manage my certificates, device commands, plugin management, as well as creating new projects, deploying them, simulating, all those things I need to do to be successful building my app. So since I already have my CLI installed and I have a browser with an internet connection, I am ready to go. My development environment is set up. I can go straight on to the next step of building my mobile app. And that, of course, is designing my app. During the design phase of a mobile app project, there are a number of goals, but the primary and the most important goal is figuring out the requirements for your application, understanding how users will use it and how your app will create value for your users or perhaps for the business that it's serving. Figuring out the requirements at this stage in the app development process will go a great way to helping you make the right decision for how to go about building your app and the next step when it's time to actually create code. This is also an opportunity to figure out the flow of your application, how users will navigate between screens, and what user scenarios your application will solve and what those scenarios look like. And of course, there's also the need to start figuring out what the screens look like, the layout, the design of your application. So while that is part of the design phase, the most critical thing to figure out is the application requirements. The requirements for today's application are actually pretty simple, and TextFX is not one of them. We need an app that will reach both iOS and Android. We want to demonstrate that we are in fact creating a cross-platform app, because if we're just creating an app for one platform, a single platform's native tools are often the simplest choice. But this is cross-platform, and when you have to build for multiple platforms, that's when you need to reach out to cross-platform tools like the Telerik Platform to expand your reach. We also need to do something native, because if you're building an app and you're not doing something that takes advantage of a native device capability, you may very well be working on a project that could be best served with a web application. So to demonstrate the fact that we do need a hybrid or a native application today, we need to access something native on a device to make that case clear. And to make this more than just a simple demo with demo data, we're going to need to connect our application to some kind of legacy data, living in an existing database or an existing system. And as you may have guessed from the name of our prototypes, we're going to work with some of the most legacy of legacy data, the Northwind database from Microsoft. The Northwind Traders Company has got their database running on a SQL server in Azure, and that's the source of our data for today's mobile app. And we'll connect to that data and provide a mobile interface so that Northwind can finally have a modern way of browsing what's in that database. So now that we've got our app design figured out, we've got our requirements sussed out for today's demo, we next need to figure out some way to make sure that our app UI can get to the data and authenticate the users that need to use the app. When we talk about mobile app development, we often spend a lot of time talking about the UI, because that's where a lot of unique challenges do get introduced. Creating UI that runs on iOS, on Android, on Windows. But before you can begin creating your UI, you must have some way of getting the data from your systems, whether it's new data or legacy, and a way of authenticating your users via those applications. Now, if you've already created a web service layer for your data, for your authentication systems, you're ahead of the game. You're ready to jump straight into building your app UI. If you do not have a web service layer, you'll need to start here before you build any of your app's UI. You can either do this manually, creating web service layers, writing code, perhaps in C#, in PHP, wherever you may feel most comfortable creating a web service layer. Or you can use tools like Telerik Backend Services in our platform. Telerik Backend Services, among many things, provides a way of automatically generating a secure RESTful API on top of your data. By default, if you create new types in backend services, we'll create those types in a NoSQL MongoDB database and also give you a place to write custom Node.js code that can execute around that data. Once you've defined your types there, you get an automatic RESTful API, completely supportable for CRUD operations, and ready out of the box for offline application scenarios, helping you cache data aggressively for performance and sync offline changes back to your database when an app is back online. And that's great when you're creating new projects and you have new data, but if you have existing data, legacy data, like we do today, our data is living in a SQL server, and it's the Northwind database, we can go a step further by taking advantage of Telerik Backend Services Data Link Server. It's a one-time setup process when you set up and install Telerik Platform. You install a data link server near your databases, and once it's installed, it creates a secure link between your data and the Telerik Platform. And once that link is established, the Telerik Backend Services can provide the same automatic RESTful API creation, complete with CRUD support, offline-ready data support, on top of your existing data sources. The data link server supports things called data connectors, which are your link between the data link server and your legacy data stores. And since Telerik has been acquired by Progress, all of these data connectors are powered by Progress Data Direct technology. And Data Direct is a longtime leader in data connectivity and data integration, which makes us a very powerful and robust way of exposing existing data from SQL Server, Oracle, MySQL, and more than 20 other data sources to your to Telerik Platform, and then get that RESTful API on top of it so you can connect it to your apps. So we're going to use this approach today so that we can expose our data to our application without writing any code and let the platform manage the security and everything else for us. And we'll also take advantage of the Telerik Backend Services ability to help us manage our users in an authentication service so that we can do that with also writing no additional code. So if we go into our project today, we've already got our prototypes now. We have our design figured out. We need to configure this data connectivity. And I mentioned there's a one-time process step involved. I've done this beforehand so that we could get our Northwind data ready to go. So I have here a Northwind data backend services project that I've previously created. And you can see on the left all of the various things that Telerik Backend Services enables you to do. Managing data is just one small piece of it. It's really a combination of data and application services. Within data, we can create new data types or connect to existing data types, as we'll be doing here in a moment. We can store files and serve files up from our cloud infrastructure. And we can even automatically serve responsive images so that you can get highly optimized images for your mobile applications and your mobile websites. There are also things like push notifications for cross-platform push, user management, both built in as well as connecting you to existing authentication systems like social networks or ADFS, and cloud code, the ability to create custom Node.js code that you can run on the scalable Telerik Platform cloud infrastructure and integrate that into your application via server-side execution. We're going to focus, though, today on a small part of Telerik Backend Services, the data piece, and we're going to focus on the data connectors. The data connectors help me establish the connection between Telerik Platform and my existing database. So we'll click here and see the connectors I had already loaded up. There we go, and we can see the connector from my Microsoft SQL Server and connected to my Northwind database. When you establish a new connector, you establish the security key to create that secure connection between the link server and the platform. And once it's then established, you can define the types you want to expose from that connector. So the tables, the views, the stored procedures, and the specific fields from those objects that you want to have that RESTful API provide to your mobile applications. I've decided to expose two types from my Northwind database, customers and employees. And so we've got that link established. We've decided which data we want to expose, and I can now begin consuming this quickly inside of my mobile app development. No time spent writing code or maintaining a service layer. Platform is handling that for me and helping me make it secure along the way. For user management, I'm also going to use the built-in user management provider in backend services, though if you wanted to, you could easily connect this to other authentication providers, as I mentioned, and that's a one-click process and a few configuration steps, and then you can use those other configuration providers. Now, as we build mobile apps, we have to be aware of the new requirements that mobile apps have made table stakes. Because our applications are always on the go, we have to assume that a mobile app is never going to be guaranteed a network connection. We must assume as we build our applications that our apps will occasionally be offline, and we need to anticipate that as we build our service layer so that we can support that scenario easily. We also want to address the idea of network latency and make sure that our apps remain fast and snappy even when the networks they're connected to are not. And since the apps are on the go, we have to be extra concerned about security. With the data we're caching on devices to overcome the offline scenario, we need to make sure that data is secure at rest, encrypted, and we have the ability to remote wipe a device once it does perhaps get lost and on the go. Fortunately, Telerik Backend Services helps us address both of these scenarios by giving us out-of-the-box offline-enabled data sources, as well as the ability to encrypt our data at rest on a device. So I'm all set there too. So with the ability to connect to our data and authenticate our users set up, step 4 is to build and debug our application UI, the meat of what a mobile app actually looks like to our users. And as you start building the UI for your app, you must of course figure out what approach you want to use. Should it be a web app, a hybrid app, or a native app? And the way you find the answer to that question is by letting the requirements drive the decision. As you work through the design of your application, you've discovered whether or not you need access to native capabilities, whether you have a requirement for rich animations. All of those requirements should help you choose the correct approach for each app you build. And there's no silver bullet. There's no one size fits all. Every app is unique, and every app has unique requirements. So it's essential that you marry the right approach to the right app to get the best efficiency out of your development process. Choosing between the approaches can depend on a lot of different factors, from team skill set to the application's requirements, the reach you need to obtain with your app. And if your app really does not need to leverage any native device capabilities, web still is a great option. It remains the fastest way to reach the largest number of screens without requiring any app installs to get your app onto new devices. Incrementally, if you do need to access device capabilities and you have a team skilled with web technologies, HTML, JavaScript, and CSS, hybrid is a great middle ground option to take advantage of all of that skill while also getting more access to a device. And there's always going to be the occasional need for a native app that has the need for full power of a device, polished animations, and native apps traditionally for a team of web developers or web skill set developers is a challenge. You need new languages, new tools, and it's very hard to move between web and hybrid development and native development. And so to solve this problem, to put native on a better equal footing with web and hybrid so a team of a mastered skill set could easily move between any approach, Telerik started working on a framework called NativeScript about 1.5 years ago. NativeScript gives you a way to create cross-platform native apps for iOS, Android, and later this year Windows using the skill set of the web. JavaScript, CSS, and an HTML-like markup, XML-based syntax. With NativeScript, you get 100% access to all native APIs on these various platforms in your JavaScript code. So there's nothing you cannot do that's native when you use a NativeScript app via JavaScript. You also get to reuse 100% of your skills and code so that now you can easily move between a native project, a hybrid project, or a web project based on that project's requirements, and the switching cost becomes very low. So a mastered team can really develop all the apps regardless of approach. And it's 100% open source. We wanted to create the de facto way for developers who want to work with JavaScript and really master that skill set of the web. We wanted to create a de facto approach for everyone to use, so we're collaborating with a lot of other large open source projects, and we're doing this all in the open on GitHub under an Apache ASL v2 license. So we'd love to have your contributions there and see us work with us to help make NativeScript the best solution for cross-platform native apps. Once that becomes part of your framework or part of your decision matrix, it's now very easy to let the requirements lead and take your skills and be productive regardless of the app you're building. And naturally, NativeScript is deeply embedded in Telerik Platform, so all the tools you're using in Telerik Platform to build hybrid or web apps can also be applied to building native apps with NativeScript. So let's get to it. Let's jump into the tools. And again, a quick recap of our requirements for today's app. Needs to reach iOS and Android. We need to do something native, and we're going to connect to that legacy data coming out of our SQL Server database in our mobile app. So let's switch over to the Telerik Platform and App Builder, where we can do a lot of today's app building. So inside of our project that we created, our Windy Data project, we have our prototypes we worked on earlier. And as you can see, with one click, I can add the various things I may need to enhance my app project, from backend services, which we're using a different project for today, as well as analytics and feedback, which we'll get to later. For now, we're going to go ahead and create our App Builder hybrid project, because today's app really doesn't need a native app, and we do want to do something native, so it can't be a web app. So hybrid is the perfect solution. And once we start a new project, we have a number of options. We can start from a template, which gives us a slightly more advanced starting point, helps us kickstart our project effort. A sample project, which is a little bit more scenario-based, a little bit more code, which we can start from and customize. We can clone a repository if we have a template out there we want to start from that's not in Telerik Platform, or we can start with Screen Builder, a new visual tool that we've added on top of App Builder to really accelerate the app development process. So I'm going to choose Start with Screen Builder. And because we've already got a project with that Northwind data, I'm going to choose Add Existing Backend Services Project, and I'm going to choose Northwind Data. We'll go ahead and call this our Windy Data app and click Create Project. Since we're using Screen Builder, what the platform is going to do now is automatically scaffold my project structure, creating my build system, my folder structure, help create my view models, my application bootstrap files, all these things which would take me time as I start new projects. Screen Builder is going to handle for me automatically and put me on the rails to building a good, well-structured, maintainable app. I'm going to land inside of Screen Builder, and here you can see it's a visual environment for scaffolding quickly my application views. This is not a visual design tool designed for dragging and dropping buttons. This is about a whole new level of productivity. So as we recall from our design process, we know that one of the views we need is a data-bound list view. So I can come in here and say, change this view type. And here you can see what I mean. We're not focused on buttons and list views. We're focused on entire views of an application. And one of those conceptual views is a data list view. When I choose a view type, I get a number of properties I can configure, like the name of the view, which I'm going to go ahead and call employees, and various configuration options which have been exposed to me via this view template. I can change the icon. I can change the data binding from our data provider. And again, we want to work with the Northwind employees data type, which we've exposed. This is live data coming off of a SQL server. And because this is a data-bound list view, I need to decide how to bind my data to the UI. And so I get this great drop-down showing me all of my available fields, intelligently being pulled out of that web service, so I don't have to guess the names. So I'm going to bind my heading text to last name and my subheading text to, let's say, job title. I even have additional configuration options for the list view, whether we want to enable pull to refresh, load on demand. We'll go ahead and enable grouping. This is using a Kenda UI list view, so that's an advanced feature that's been made available. We'll go ahead and group by the country in which our Northwind employees work. When we click Apply, we're going to see a real-time interactive preview in the simulator here on the right, so that we can immediately begin interacting with and exploring our application to see if it does what we want it to do. And so here we go. Live data being pulled out of SQL Server via our backend services in the data link server. I can interact with it here. I can scroll it. I can see the data that's being bound. And if I were to stop just here for a minute and step away, this is a step in a project where if I were doing this all by hand, it would have probably taken me at least an hour or more to get everything set up, my build configuration created, my web service bound in, to get to this point where I have a data-bound list view with a template that's ready to go. So what traditionally would take a long time as a developer, it's now been handled for me in just minutes with a few clicks in Screen Builder, really accelerating my progress in the project. So even if I want to do things that are custom, I now have a lot more time on my plate to go back and do those custom things that Screen Builder can't do for me. So it's a pretty cool feeling to get this far this fast. Now, under the covers, Screen Builder is using a Yeoman generator, so it's a great extensibility point for our enterprise customers to go create a standard set of view templates if you really want to help your users stay on a uniform path, creating apps that conform to standards established within an organization. These templates are easy to create, and you can decide what properties to expose here in the Screen Builder property window I'm working with. A more advanced option for this view is this master detail option, where I can click Enable Details View, and I can say for the heading text of my details view, I still want to show that last name, and for the description, maybe I want to show the notes for each employee. And when I do this, I'm going to see Screen Builder automatically create a second view for me that I can navigate from my data-bound list view. So now when I scroll through this list and click on an employee like this, I can see that nice mobile animation, an automatic back button navigation has been added, and I see the notes field for my different employees. So an additional view, additional data binding, this time done with literally just a couple of clicks. So I'm feeling good about this. I'm feeling like my app is coming together. We had one more view we knew we needed to create, and that was the sign-in view. So I'll go add an additional view to my application, and we'll choose this authentication view type. I'm going to go ahead and make the name of this view a sign-in view title. Now, intelligently, you traditionally don't want a sign-in view in your navigation, so we're not going to include that as our template has suggested. Our data binding has already been set up, and as I mentioned, we're going to use the built-in user authentication provider in our Telerik Backend Services project. And we have a number of other options we can configure, like the text box label for our username or email, some help tip text. We can do that for all the various UI elements in our sign-in screen, as well as telling our sign-in screen where to send people once they've successfully authenticated. Now, we only have one other view in this app, so we'll send them to that view. And we can also provide a registration screen and link automatically, another automatically generated view that's created if we want to allow people to create new accounts when they interact with our application. So that's a great thing for us too. We'll click Apply, and we can see this view now generated, and in real time we interact with it in our application, and there we go. We can see we've got a sign-in view, a register view, which we can flip between, and we could even begin signing into and interacting with our application directly from the simulator here, but we'll do that in just a minute. So we can keep going through this process, building up these conceptual views. We can even control our application's navigation type if we had more views we wanted to manage, whether it's a tab-based navigation or drawer-based, and which view we want our application to show when it's initially loaded. And since we want some authentication to take place, we'll make that initial view the sign-in view. We could configure additional data providers, the theme for our application, but as you can see, it's a very fast and rapid way to scaffold the skeleton functionality of our application. And for a lot of simple applications, this is all you need. You could begin publishing out directly from here. We want to extend this, though, and this is part of the beauty of the story of Screen Builder, is it's built on App Builder. It's built on a foundation that developers can trust, and it's built on code that developers can maintain. We know a lot of developers are very weary of visual design tools, so we've gone to great lengths to make sure what Screen Builder doesn't give you a bunch of garbage code that's terribly difficult to maintain. So as we can see here on the right, Screen Builder has already set up a folder project structure for me, and here's that default home view with the default view details, and then the master detail view also generated, and an index.js file that has all the model view information for this specific app view. And if I open this up, we can see the HTML is nice and clean, and MVVM syntax already in place here, along with UI binding templates. We're using Kendo UI Mobile here to help provide some of these out-of-the-box capabilities. So very easy to maintain and extend. In fact, maybe we're saying that for that first view where we have last name, we'd really prefer to show first name, last name. We couldn't do that easily from Screen Builder today. So I can come in here and modify this template, and I already know that first name is another available field, so I can say first name. And with just a little bit of modification here, I can now collaborate with anybody working in the Visual Screen Builder by adding additional capabilities in code and make my app a little bit more custom and functional. And once we've done this, we have the full power of App Builder available to us. All of the in-browser simulators we can run, like the Android, iPhone, Windows simulators. And to clarify the vocabulary, a simulator is an approximation of how your app will run, but it is running in a browser. The next best place to test your application is an emulator, like the iOS or Android emulators, and these will actually run versions of the mobile operating system on your computer so you can see how your app will actually run in that mobile OS. And the best place to run your app before you deploy it out to users is, of course, on the metal, on a real device, so you can see how your application performs in that real environment. But a simulator and an emulator are great ways to find the quick, easy problems that you can fix before putting your app on a device. And we've got some great options here in the simulator, and I can begin logging into my application. And I've previously created an account, so I can do that quickly. I can sign in. Don't need to save that password. And when I do, here's my application. I can interact with it. I can navigate to employee views and make sure that it's functioning the way I expect it to. But what we'd really like to do at this point is sort of see our app on a device. And one of the neat things about a cloud-based infrastructure like Telerik Platform and App Builder is we can do that without any complex build steps or certification process by using something called the App Builder Companion Apps. These are apps available in the iOS, Android, Windows marketplaces, in their app stores that you can download and install now. And with these companion apps, we can put our app we're working on our device instantly without the need to do any complex build or anything else. So I'm going to actually try to show you that on my physical device here. We've been given a QR code which I should be able to scan on my device, which I will now mirror here on the screen. So here is my device. We'll put this over here. And I have the App Builder Companion app already installed, which I'll launch here from the center of the screen. And if I do a two-finger swipe in this app, you can see I can pull out the little drawer in my App Builder Companion app, and there's a QR scanner option right there in the app drawer. And if I tap on that, get a little QR camera, scan that code, and it's going to download now the content of my app and load it in this companion app, and I will instantly see what my app looks like now on real hardware. And there we go. Here's my app. I can begin interacting with it. Todd Anglin at Gmail, and we're using the email input type in HTML5, so we get these great keyboard shortcuts. Type in my super secure password and sign in. And there we go. This is data, again, I'll keep saying it because I'm always impressed myself that I can do this so fast. Data from a SQL server over a secure RESTful API in an application that's running on my actual iOS 6 device here. It's an iPhone 6 Plus and mirrored to the screen. Navigation's all there, all looking good. So a great little test to show how quickly we can get onto the device. Now we can go forward and do a lot more. So let's go back over to App Builder and figure out what we want to do next. So we said one of our requirements was that we want to create an app that runs on iOS and Android. So far we've seen it running on iOS. What if we want to see it running on Android? Well, we of course could do the exact same thing we've just done, launch this in the Android companion app, or we could even show it in the Android simulator. But just to show you the breadth of what you can do with the Telerik platform, I'd like to show this to you now running in an Android emulator. And the best way to collaborate with different environments, whether it's the browser-based tools we have here or maybe a Visual Studio plugin environment where you're working on your code, is of course over version control. We have complete built-in support for version control in App Builder. So I'm going to go ahead and publish this code to a remote repository, and I'm going to use my GitHub account to do that. So I've already put in my credentials, so we're already wired up, and I'm going to go ahead and call this Windy Data Demo. And we'll just leave the description blank for now. And I'll come in here and click Create to create my repository. And now we can see we've already selected that my Windy Data Demo is where I want to push this code I've just created in App Builder. And I'm going to go ahead and make myself the main collaborator, but I could invite others at this point. And when I click Done, this is going to automatically take all the code App Builder has created so far and put it in my GitHub repository. So we'll go ahead and say Done. So push that all out. And now we've got our code living in a Git repository and in GitHub. So take everything I've done so far and make sure it's in there. I'm just going to go ahead and commit all of my changes. So you can come in here and we get this great interactive view to see what's changed since our last commit. So I can go ahead and just say commit and push. I'll be a bad contributor and not add any useful comments for now. But now it's all out there in our GitHub repo. I can actually grab the URL for our GitHub repo now, which I'm going to do, just copy from this link. We're going to go over to that command line interface we opened up before when we got our development environment set up. So in here, first thing we need to do is bring our code into our local environment so that I can run it on a local Android emulator I have installed. So I'm going to go in here and say git clone that repository we just created. It's going to pull down all those assets, including anything we've configured in our project, to my local environment. Now that it's here, I can navigate to that folder, and within that folder, I can now start using the App Builder CLI. So we can actually navigate into our Windy Data app folder. And there's all of our code created by App Builder. And so if we want to emulate this, we will say App Builder emulate. And if I just stop there, I'm going to get some tips on how to use the emulate command. It shows I need to specify a platform, and there's some other options I have. And in the case of Android, I want to run this on the Genymotion Android emulator. It's a far faster version of the default Android emulator and a much better debugging experience than working with the default Android emulator as well. We provide built-in integration with Genymotion, so it's easy to use. The only thing you need to use it successfully is the name of a virtual device you've configured within the Genymotion emulator setup. So I'm going to use their own command line tools called GenyShell. I'm going to fire that off to get a list of the virtual devices I've created. So I can say devices list, and here are my virtual Genymotion devices, and I've got one that's running Android 5 here. I'm just going to copy and paste this name. This is a good PSA to remind you that shorter device names can be better. I should probably shorten these device names up to make it easier to remember. So we can go back to the App Builder CLI now and say App Builder emulate Android. And because we want to use the Genymotion emulator, we'll say --Geny and then provide that name of the device we want to run on. So I'll go ahead and hit enter. And what this will do now for my local environment is take all of my code from my application, upload it to the Telerik Platform build servers, build my Android application, create the APK, download it once it's done, and then automatically launch and run that in an Android emulator. So we can see our application running on actual Android OS. When this is complete, we will have now, in just the minutes we've been together, created a cross-platform app that's running on iOS and on Android, and we'll have put it on the actual operating system, one case on the Metal and the other case on the emulator, without doing any configuration or environment setup. It's all here ready for us, ready to go, and it's taking us no time at all. So let this load up. Now, as this loads up, let's start thinking about the next thing we need to do, because we have already gone iOS, Android. We're connecting to our legacy Northwind data. We also said we need to do something native. So once this thing loads up, we need to go back to our App Builder project and figure out what is that native thing we can do to demonstrate that what we're doing today deserves to be an app and not just a website. So here we are in the Android emulator that Genymotion provides. Loads up so much faster than the default Android emulator. And there's our sign-in view. So here's our application running on Android. We could sign in on Android just as we did on iOS, just to demonstrate completeness. And we sign in, we get the same complete functional application here as well. So there we go. We're off to the races. So let's figure out what is that native thing we can do in our application that we can show today in the webcast. Now, when we talk about doing native in a hybrid application, that means a plugin. Plugins are where you have the ability to interact with native device APIs and hybrid apps. And you can manage the plugins in your application in App Builder via the Properties screen. In fact, you can manage a lot of things about your application from the Properties screen, like your application identifier. This is very important, particularly when you're doing apps for iOS, because you need a signing certificate that matches your app identifier. So I'll go ahead and put mine in there. And you can configure a lot of other things in here as well, like whether or not you want to allow portrait and landscape orientation for your app. What the icons and splash screens of your app need to be for each target platform, permissions you want to request, devices you want to support. All of that can be quickly configured here in the Properties screen. And then, of course, down at the bottom, there's plugins. We provide a lot of plugins out of the box that you can simply check a box and enable. These are default common Cordova plugins. You can also import your own custom plugins if you have your own. If we scroll down here far enough, we'll see another option called Install from Plugins Marketplace. And what that's referring to is the verified plugins marketplace that we've curated over the last year or so, where we have worked hard to make sure that the plugins we curate are tested, documented, and guaranteed to work when you import them into your hybrid project. Today we feature plugins for Apache Cordova, and of course soon we'll also have plugins for NativeScript as well. So if we go into the Cordova plugins marketplace, we can see that there are now almost 60 different plugins in here, again, all documented. And unlike the Wild West of just random repos of plugins, these things we've worked on to make sure that they do what they're supposed to do. So since I can't show you a flashlight or something else on the hardware over a webcast today, we need to do something that can be shown on the screen, and the action sheet is as good as any plugin to make that happen. So when I click on a plugin in the marketplace, you can see I get all kinds of useful information, documentation, code snippets, how to use the plugin, as well as screenshots showing me how that plugin should look when I load it up on my device and get it going. I even have quick shortcuts here to load that plugin up in App Builder or use it in the Cordova CLI or the App Builder CLI. Again, marketplaces for any Cordova developer. But remember that button in App Builder, install from Marketplace. We can actually do this without ever leaving the App Builder interface to add these plugins to our app. So when I click that button, you can see I get an interface here, which not only allows me to load in Bower packages and Kenda UI framework versions, I can load any plugin from that marketplace. I can search for it, but here I see it right on top, so I can select that and go ahead and just click install. This will now import everything necessary to make this plugin part of my application. So the only thing that's left for me to do is actually implement or use that plugin in some part of my app. So we can go ahead now and go back to find a place where we can invoke that native plugin. The simplest way to do that, I think, is just to create a button somewhere in our app that we can click to show that action sheet native element. And so on our authentication view HTML, let's just go ahead and add an additional button to do that. So I'll copy one of our existing buttons we already have and paste in another copy of it here. And rather than binding to the authentication view model toggle view event, we'll go ahead and bind to some new event we need to create, a new action handler called action sheet. And we'll change the text of our button from register to action sheet. So now we have a way of invoking our action sheet, and in our code for this view, we need to modify our view model, which again was all created for us automatically by Screen Builder when we initially set up our application. So I'm not the best developer in the world, I'll admit to that. This has already helped me create better code than I would have on my own by giving me some best practices as it set up my application. So we see our function for sign in, for register. Let's go ahead and create one for action sheet. And we'll go ahead and create our anonymous function here. And now in classic copy and paste development form, we'll go back over to the marketplace where we originally reviewed the documentation for this and just take this snippet documentation they've created, the code snippet, to help us implement this in our demo. Let's paste this into our demo, and we can see what this does is it provides some configuration of the options the action sheet requires, basic text and prompts, and then provides those options or passes those options into a call to window.plugins, gets us into the hybrid plugins namespace, actionsheet.show. The only thing that it also requires is some kind of callback that gets called once you've clicked a button in that action sheet. We'll go ahead and just provide a dummy inline function for now rather than creating a standalone callback function. And we'll simply alert whatever index it is that someone has clicked. So we'll say index, and then we'll simply display the index of the clicked action sheet button. There we go. So now we've implemented the call to our plugin, but now that we have a custom plugin in our application, the companion app really isn't going to be sufficient because the companion app obviously doesn't have all these plugins baked in. So we now need to create a complete build of our application. So for the sake of completeness, I'm going to go ahead and commit these changes to our source control. I'll just go ahead and commit and push so that it's also available in our remote repository on GitHub. And then in my project, I'm going to go up here and say run and build. I'm going to go ahead and build an actual complete app package for iOS. And since I'm building for iOS now, once we go to a full build, we need to have our signing certificate from Apple available, along with the device identifiers for the devices we're allowed to install these apps on, per Apple's rules for how we install install apps on devices. Some of this is changing now with iOS 9 and some of the new Apple programs, so hopefully this will continue to get simpler, but for now we need this signing certificate. So I'll go ahead and click Next. And now this build is running in the cloud. So I'm about to get a complete iOS build for my app, and when it's done, I'm going to get a QR code I can scan and directly install this app on my device because it's part of that list of device IDs without needing to connect anything over USB or do anything else. I'm just going to get that app I can install on my device. While that's running, let's go ahead and download the latest code we've got in our project locally by doing a GitHub update or a Git update. We'll just simply say git pull, get the latest version of our object with that new plugin we've just added. Let's go ahead and also do a build for Android. So we can come in here and emulate again. And when we do an emulation, it's going to go ahead and do a rebuild of our app in the cloud. So we'll just kick that off and let that start running as well. So we can see how this plugin looks natively both in iOS and in Android, further verifying we've done all the right things. So our build for iOS is just about complete. So let me go ahead and open up my reflected view of my app for you again. So So we'll bring this up on screen. There we go. Move this over. So let's go now ahead and open up a generic QR scanner to scan the code we've been given here. This is not for a companion app. And when I tap this link that this refers to, I'm going to get a prompt to install my Windy Data app. I'll go ahead and click Install and Done. And now we should see that my app is being installed on my device screen. We see it in the bottom right there. There it is, installing. And we tap on that. Our app loads right up on iOS. And there's our new Action Sheet button, which is invoking our new plugin for a native capability. So we can tap that. And there it is. There's our native iOS action sheet loaded up with completely irrelevant text because we did not modify the copy-paste snippet, but we see it functioning in our iOS app, so that's great. We're doing good so far. Let's see if the same thing works in Android. Oh, there's our index alert in the Android Genymotion emulator. So we'll go over to Genymotion again. Let's see where we're at in the build process here. See if we got this all loaded up. We may have a cached version of our application loaded here because we did not close the emulator, so we may have to run this again. So we'll just let that close, and we'll run this again in the background, and we'll come back and check in a minute to make sure that what we did for iOS also works for Android. But so far, I think we've met our core requirements. We've built an app that runs on iOS and Android. We've done something native. We're also connecting to legacy data, pulling it out of SQL Server and Northwind and connecting to our app. What's next? Instrument with analytics. Before we push this application out to our users, even in beta testing phase, it would be great to know how our application is being used. And in the space of analytics, there are a few different kinds of analytics available to you: quantitative, qualitative, and marketing. Quantitative analytics is, of course, the charts and graphs that give you the summary view of how your application is being used, where it's being used, when it's being used. And in the case of Telerik Analytics, as part of the Telerik Platform, we also give you a lot of detail. There we go, let that run. A lot of detail about the features in your application, which features are being used, how long are those features being used, and crash reports to help you make your application quality even better. Qualitative analytics, meanwhile, is about getting feedback directly from users, less about the summary stats, more about the direct user input. And Telerik Platform actually includes an app feedback module, which helps you quickly and easily collect screenshots and commentary from users of your app so that you can figure out where they're getting stuck, what they like, what they hate, so you can make your app better based on direct user comments. And then there's a whole category of marketing analytics you can also embed in your application for things like A/B testing, ad optimization. So if you're building the kind of app that depends on ads or that really needs to optimize the experience for conversions, those are also things you'll want to embed into your app experience. With Telerik Platform, we can easily embed quantitative and qualitative analytics with our Telerik Analytics and app feedback modules of the platform. So let's also quickly do that today. So we'll go back over here to our platform environment. And you may have noticed when we were configuring our properties, in addition to the core plugins that we have here in the import from the marketplace plugins, there are a few other default options we have below, like Telerik Analytics and Telerik App Feedback. When I check this button, it's going to automatically help me create a new analytics project and wire that up to my application. So I can go ahead and say a new Windy Data Analytics project. And when I do that, it's going to intelligently detect that I'm working in a JavaScript environment or a hybrid project and give me the appropriate code snippet, which I can copy with my API key already embedded and embed into my application. It just needs to go somewhere where my application starts, so I think my app.js file is as good as any to place this. And then it tells me that the one thing I need to do is find a place to say window.analytics.start to kick off my analytics monitor. And the monitor is the thing responsible for collecting all the stats about how my app's being used and then sending them up to the analytics server for aggregation and analysis. Even works offline, so you don't miss anything even when your app is not connected to the internet. So I'm going to come into this device ready event, again, the right spot in a hybrid app to start doing things when our code can execute, and drop in my window.analytics.start event call. So there we go. A few clicks, and I'm automatically now wired up to start collecting aggregate analytics on my app, the quantitative values. Let me also quickly add qualitative feedback via the app feedback plugin. Similar to analytics, I can create a quick app feedback project, Windy Data Feedback. Click Next. It'll also give me a small snippet I can copy and paste into my application. And now, similar to what I did with analytics, I'll put this in my device ready event. Now, I don't need another device ready event listener from that snippet, so I can just bring this part Make sure I have my semicolons, and I'm all set to continue. So now I have 2 new plugins in my application, which means I do need to rebuild my application again. But when I do, I should be able to start collecting analytics and see the application feedback experience in my app now that those plugins are embedded. So once again, I want to see these on my devices. So I'm going to go ahead and initiate a new build for iOS in the cloud with my appropriate signing certificate. And let's go ahead and do the same thing for Android. Let's go ahead and close our Genymotion emulator and come back here and initiate this for Android. So we'll go ahead and make sure we've got all of our latest changes again, which we actually did not commit, so we may not get those changes here. So let's wait and do Android later and just see how our iOS build proceeds. There we go. There's our QR code again for our recompiled application on iOS, and I'll get my device back up here on the screen so we can scan and install this app package. We'll download and install that package with all of our plugins embedded. And once our app has been installed, we can open it up. So we'll see there's installing in the bottom right corner. Installed Windy Data app. We can launch that app. All these splash screens and icons, of course, we can customize. We just haven't done that today. Our Action Sheet plugin is still there, that native capability. That's great. Our analytics are now working behind the scenes. We can't see that, but we're now beginning to collect stats and feedback about how and where I'm using my application. And my app feedback plugin is pretty cool. If I shake my device, which you can't see, but I just gave my device a little shake, automatically pops up its own action sheet and gives me the opportunity to send feedback on this app I'm using. It automatically takes a screenshot of wherever I'm at in the app, and I can tap here on different places, like right here, and provide a comment like, should, or maybe if I'm a user, is this my username? Question mark, done. I can send that comment along with my screenshot. I can choose to send it anonymously or provide my name. I'll go ahead and send it with my name. And that's going to send it directly back to the team working on this app. So if you're a Telerik Platform customer building your app with a platform, this will be feedback you can use to make the next version of your app even better. So as we zoom out of our code and look at our other projects that have been created, here's that feedback project and one new piece of feedback in the last 24 hours. As we zoom in on this, we can see here, in fact, is that piece of feedback we've received. Is this my username? When we click on this, we can see the screenshot the user provided, the device OS version and platform that it came from, along with the commentary and the ability to reply and have a conversation with this user to make the app better and make their experience with the app the best it can be. When we're done, we can resolve the issue or even reopen it or assign it to other people on our team. So meanwhile, while this is happening in the app feedback space, our analytics are running, collecting data on our application. And if we look at the analytics project space, there won't be a lot there right now because we don't have enough data to make our summary dashboards fill up. But you can see the kinds of things we'll be able to start seeing, like activity reports, world maps for where our users are, the kinds of devices they're using, feature reports where we can start tracking specific features we care about, see how often they're used, as well as things that are valuable to developers like exceptions and exception timelines, and even live session views. So as live sessions take place and get started, we can browse them here in our analytics dashboards. And if you have other stakeholders in your project who want views of how your application is performing, you can create custom dashboards and even PDF report exports to quickly and easily share these dashboards and get more people involved in the app development and improvement process. So now that we have an application that's been designed, connected to data, we have our UI built, we've instrumented with analytics and feedback, the next step would be to test this application. There are two kinds of testing you want to do, of course. Local testing, which we've been doing on local devices and emulators to make sure that it performs at least acceptably on the devices we have on hand. But before you publish it broadly to an app store or to a larger group of users, that device cloud test step is very valuable. And the reason, of course, is because of this problem, fragmentation. With Android alone, there are more than 18,000 different permutations of hardware, screen size, operating system, and this was a report that was done by OpenSignal just last year. And it's not just operating systems and hardware vendors you have to worry about. Across iOS, Android, and other device makers, there's also a growing number of screen sizes and screen orientations, and even app models like the new docking apps in iOS that you have to be concerned about to make sure that your application works and functions the way you expect it to on the hardware your users have, not just on the hardware you have handy at hand. So Device Cloud can help you do this and do it scalably without needing to manage the entire device center on your own. Telerik Platform provides a completely integrated way of creating these automated functional UI tests and is seamlessly integrated with device cloud testing as well. So you can upload those tests, run them on real devices, and get reports back that show you what broke, what worked, and help you make sure your app is running as good as possible before you push it out to an app store. Which brings us to that last step we have here, which is how do you, in fact, then deploy an app you've built and tested to your users or your beta testers, whoever that group is, beyond your local development environment you want to get your app out to. And to do that, you have a number of choices and options. Of course, a lot of apps end up in public app stores, and a public app store app is available to everyone, whether it's for a partner or a consumer. There's a lot of testing you want to do to get it into an app store, and there's a lot of vetting that goes on by the app stores themselves before your app is displayed. If your app is for a more targeted audience, a private app store may be more appropriate. And there are a lot of solutions out there for providing you with those private app catalogs and stores, and Telerik Platform offers this opportunity to do this as well via Telerik App Manager. App Manager helps you deploy apps to users directly or create a catalog of apps that you can provide to a named group of users. The other way to deploy an app is, of course, direct distribution. As we saw in our app development process, with just a simple link, as long as an app has been configured correctly, users can download and install the app directly without needing to go through any kind of app store catalog. And Telerik App Manager also facilitates this kind of distribution too. So as a final step in our process today, let's go back to App Builder and let's deploy our app via Telerik App Manager. In App Builder, one of the buttons we have not clicked today is the Publish button. And now that we've got an app that works, it's instrumented, we've got some plugins, we want to go ahead and publish our application. But today we don't really want to publish our application to a public app store. We want to publish it to App Manager. And we need to choose what kind of package we want to create. So let's go ahead and just say an iOS package and click Next. Of course, you're going to need the right signing certificates again for iOS apps, and we have lots of documentation to help you through that process. And then we'll go ahead and create the new package build again in the cloud. Only this time when we're done, we won't get a QR code. We'll go ahead and publish that new build directly into App Manager so you can manage who can access it, who can install it, and even configure some details around that app to make it a rich part of your app catalog. So while that build is running, let's go ahead and take a look at App Manager, which you'll see on the right side of your screen whenever you launch Telerik Platform. Here I can go ahead and open App Manager. And we'll see in here some other apps I've created and published in the past. And for every app that you create and publish here, you'll see that you have the ability to come in here and edit the app, change the details for the application, provide a description, screenshots. It's really like managing an App Store description page, as well as deciding who can install or not install this app from the groups of users that you've already defined. You have the ability to create different groups, the devices that that group has, the apps that they're allowed to install, and invite additional users into these groups. Invite them or import them so that you have this group of people that you trust to test your apps. And I've got a handful of, I have 2 loyal testers here for some of my apps in this account. A great way to get apps out to a large number of users, to manage those apps and publish them. And once you're ready to publish your app, here's our Windy Data app. It's now joined us here from App Builder directly. We can either grab the link and send this directly to our users, and they can install this without any extra steps. So you could send this out over a text message or an email, or we can choose to publish this application and send email notifications and push notifications automatically so that they can know that there's a new version available and they can install that app on their device and begin testing it. Or in the case of a user, begin using the app. So great additional final seamless step for getting that app you've built and tested out to your users or your beta testers, all integrated and seamless in the Telerik platform. So now that your app is out there, it's time to lean back and collect that feedback. Look at what comes in through the analytics, look at the feedback your users send, and make your app better. No app is perfect the first time through, and many apps fail because they don't evolve and respond to the actual needs that the users have. So while we did a lot of time, or we should have spent a lot of time in that design phase figuring out the right requirements, the key to your app success, beyond your technical success, is making sure your users get the right value out of the app you've created. So lean on that feedback and keep making your app better. We've covered a lot of ground today in just about an hour. We've gone all the way from the idea for an app to actually putting the app on our device. We've seen the steps that it takes, and we've successfully gone through designing, connecting our app to data, building and debugging, instrumenting with analytics, and then eventually even deploying it out to our users. As you can see, Telerik Platform brings all these steps closer together and tries to help you be as successful and productive as possible as you go about building these mobile apps from multiple platforms, whether it's hybrid, web, or even native with NativeScript. I hope you've enjoyed today's content. The next thing for you to do, and I hope you do it right away, is to join us on platform.telerik.com and start building some of your own mobile apps today. And if you've already checked out Platform in the past, I encourage you to come back and check it out again. We're shipping new updates every 6 weeks, so there's probably something in there you haven't seen before that will make mobile app development even easier. We're now going to transition to a live Q&A and try to answer some of your questions here before we wrap up officially. But if you don't get to stick around, if you have more follow-up questions, you can find me on Twitter at Todd Anglin. You can always email me at todd.anglin@telerik.com. And thank you again to everyone for joining us for this webcast. We wish you a lot of luck, and we hope you have a lot of fun building mobile apps with the Telerik platform. And we hope to see you again at another Telerik webcast.